Good day, everyone. The topic before us is modular arithmetic. But before we dive into it, I would like us to know one or two few things. That the most simplest thing we need to know, or the easiest thing we need to know in mathematics before we get into the complex part, is trying to understand the basic part of the topic we are trying to work on. Once we understand the topic, the basic part, those tiny trivial little things, the complex question from such topic will never be difficult. But by the time we ignore the simplest or the basic part of the topic, we'll have problem along the line. On that note, I want us to give this rapt attention as we are about to unveil the meaning of the word or the phrase modular arithmetics. Modular arithmetics. We are done with circular variables, which you see here. Now we are on modular arithmetic. What is this modular arithmetics? Remember, when we talk about circular variable, we talk about something moving or revolving around the circle. Modular arithmetic have a similar relationship with circular variable. Modular arithmetic means also a distance around the circle, but it comes in a bit different from what circular variable is. Now, what is modular arithmetic? Modular arithmetic is an operation. It's an operation which gives a remainder when an integer is divided by a non-zero fixed integer. Look at it. Modular arithmetic is an operation that gives a remainder when an integer is divided by a non-zero fixed integer. What do you mean by this? Look at it. Modular arithmetic is an operation that gives a remainder when an integer is divided by a non-zero fixed integer. For instance, let's take a look. Let's say we have 5 divided by what? 3. Now, instead of having this 5 over 3, we'll say is equal to what? 3 in 5, you have what? 1. Remainder what? 2. So in modular arithmetic, instead of writing 5 over 3, we write what? 2. What is the divisor? 3. We say modular 3. So this is the remainder we are talking about. Look at this one. 7 divided by what? 4. So instead of having 7 over 4, what do? We say 4 in 7, we have what? We have 1. Remainder what? Remainder 3. Pardon, please. So instead of having 7 over 4, we have what? 3 divided by what? Modulo of what? 4. So this is what we meant by this definition that what? Modular arithmetic is an operation that gives a remainder. Look at the remainder. When an integer, where is the integer? Integer 7 is divided by a non-zero fixed integer. This is what? An integer that is not 0. So when it's divided by it, you have what? Left remainder of 3. So instead of writing 7 over 4, we write 3 modu 4. Moduli 4. This is what this definition is talking about. Now, if we forge ahead, we can now use the understanding to say, in modular arithmetics, we represent our integer by the remainder. You can see what we did in that demonstration, that where we said we have 7 divided by 4. This was supposed to be, but in modular arithmetic we say no. 4 in 7, 1 remainder what? Remainder 3. So we write that 3 modular 4. That's what we mean by this second paragraph statement. Now, we say, in modular arithmetics, we represent our integer by the remainder. Hope we get the point. Now, we can say, when an integer is divided by 6, the possible remainder are 0, 1, 2, 3, 4, 5. These are the possible remainder. Somebody say, why are you saying 0? No, when you say, okay, for this time, if I say 2 divided by 2, 1 remainder 0. You can see that here. Now, somebody say we are divided by 6. In our normal division, you know that what? When the dividend and the divisor are the same, you can call that a value of quotient. For instance, if you have a dividend like this, let's say 8, and you have a divisor like this, let's also say 8. Can you say 1 remainder for this? It cannot. You can't have 8 as a remainder. We can't have 8 as a remainder. Now let's see. Let's go. Check this. 5 divided by 3. In long division, you have what? 3. Here is what? 5. 3 in 5, 1. 3 times 1, 3. You have what? Remainder 2. You say 1, remainder 2. So, these are the what? These are the possible remainder. When an integer is divided by 6, the possible remainders are 0, 1, 2, 3, 4, and 5. These are the only possible remainder we can have. If it's divided by what? 8. If an integer is divided by 8, the possible remainders are 0, 0, 1, 2, 3, 4, 5, 6, 7. Are we seeing it? Now, excuse me. We are back. We said the possible remainder are 0, 1, 2, 3, 4, 5, 6, 7. These elements, you can see these elements of what? The divisor 6 and divisor 8, the integer for module 6, the integer 0, 1, 2, 3, 4, 5 for divisor 6 is called element of 6. Why the operation is modular 6. So also for what? 8. We say the integer 0, 1, 2, 3, 4, 5, 6, 7, 8 are all elements of what? Divisor 8. If you're talking about what? The divisor of 8. Why the operation is modular 8? Think we're getting it. Now, we could now be asked that there's another point. Now, let's talk about what we call equivalence. Equivalence. Two integers are said to be equivalent when they have the same remainder in one modular, in a modular. E.g., 2, if you say 2 divided by what? 5. 7 divided by 5. 17 divided by 5. What do you notice? This is what 0 remainder 2. This is what 1 remainder 2. This is what 3 remainder 2. Therefore, we can say 2, 7, 17 are module 5 are equivalent. Then the congruence. When two integers have equal modulus equivalent, they are congruent. When two integers have equal modulus equivalent, they are congruent. Think we are getting the point from here. 2, 7 are what? Congruent with what? Module 5. Now, this is what? The basic thing we need to know about what? Modular arithmetics. Now we know how to get what? We define modular arithmetics. This is what it is. We explain how we get the integer, how we get equivalence, and what? The congruence. Make sure you understand this. Note everything down. I believe you do well. The next thing we'll talk about are what? If we are having a question, we are asked. Write out, okay? Now, let's say we are asked a question. We are asked to find this. Write out exercise. Write out the integers or element of the moduli below. 12. Mode 12. Mode 8. Let's say this is mode 8. Mode 7, then mode 12. The element that the possible remainder we can have if we are to use mode 7, from what we said, is always what? 0, 1, 2, 3, 4, 5, 6. Why don't we have 7? We said modulus works like what? A circular variable. You must have it moves around a circle. So you have to initiate a point where it is starting point. That is what? Let's say point 0. So you have what? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. For module 12, the same thing. You have something similar.